All right, how do we start solving this? Cross multiply. So when we cross multiply, we need to multiply this to everything and this to everything. So 6 times x plus 1 equals 18 times x minus 5. And then how would we start solving this? Distribute. So 6x plus 6 equals 18x. What's 18 times negative 5?
90.
Negative 90. And then from here you have a choice. What do you want to move? The 6. I heard the 6 first. The 90 would make less negatives, and that's okay. So we have 6x equals 18x minus 96.
Will this be on the test?
No, we've already tested this. And then how would we solve for x? Move 18x over to the 6x.
Yeah.
Monday.
It's Monday, not Tuesday.
Today's Monday?
No.
Oh, exactly. That's what I'm saying.
No,
Yeah,
you guys have the test
yeah.
Monday.
Today is our next class.
Man, that week will look like fast.
What is x?
8.
8.
Oh,
That's what
I will say this, because we don't have time to quiz and test. But your Khan Academies are mini quizzes that you can do over and over again. That's
Yes.
the point of those reports. You can do them so you have practice. Okay? Make sure you have this written down. Make sure your name is on your answer sheet because these are new answer sheets. If you are around an empty desk, pass theirs up as well.
her jeans are her DNA jeans.
Look.
Alright, I'm going to go over the answers to the homework. If we need to go over any, we'll probably do that after lunch. So check your answers. Number 1 was 2, 2. Number 2 was 2, 0. 3 was negative 3, negative 1. 4 was 2, negative 3. Now for 5 and 6, you didn't really have to do substitution or elimination or graph them. You could have just put the numbers in and see which one equaled both. But B, negative 2, negative 3 was your answer there. 6 was B also, 4, negative 3. 7 was C, small box was $5, large box was $16. And again, that was one you didn't have to do you didn't have to do all of the work, all the substitution or elimination or graphing work, because once you have your equations, you could have just put those in and see which one worked. But if you solved it, that's fine. And then 8 asked about how many students attended the game, and that number was 145. Do we have questions on any of these? None.
Did you get 145 students for number 8?
We'll do that when we come back.
Oh.
Okay, you can go grab your phones. Okay, so really fast, we're gonna go over how we got 145. I am gonna do this the graphing method. So remember, for each of these types of problems, you have 3 ways to do this in your toolkit: elimination, substitution, or graphing. So in this, it says Colgan is selling tickets for the boys basketball game. Adult tickets cost $5. Student tickets cost $3. On the night of the game, 250 tickets were sold, totaling 960. What would the equations be for this? That would be one of them. A plus S equals 250.
The other one be like 960.
Oh, it's the whole.
It's going to equal 960.
I was
So
like,
it'd be like 5 something very plus whatever the other one is.
I just need you to put all those
Wait, can you-
pieces together.
Can you just put any variable or no?
Well, we already have 2 variables, so we have to use those 2.
Okay, 5A plus 3S.
5A plus 3S. Alright, once you have, now we didn't do this and we should have specified what A and S were, but A and S are going to be the number of student and adult tickets. We just didn't write that. When we graph this, in your calculator or on Desmos, you need X's and Y's. Here we don't have X's and Y's. But if I make AX and SY, and I put both of these in Desmos, it's going to give me an ordered pair just like it would any other time. I'm going to type that from my laptop. So instead of A plus S equals 250, I'm going to put X plus Y equals 250. And then the other one, I'm going to put 5X plus 3Y equals 960. Now, nothing happens at first because the numbers are really big, so you have to zoom out. I'm going to zoom out over here. Oh, I drew instead of zooming out. I have to pick a picture. Here we go. So zoom out and then find that ordered pair. Still gave us the solution, but we have to remember which variable is which. So this is X, this is Y. X was A, Y was S, so 145 was the student tickets. So you can use this for your word problems. I just have to see your graph, just like any other problem, and your solution. Okay. Other homework questions? I'll let you check them. So B and D. Okay. Does everyone have a Unit 5 review packet? We're not going to go over every single thing, but we can go over half of each section. I do want to re-emphasize this. If you can use Desmos on your phone while we're doing this. If you want to only use Desmos as your form of solving, that's fine. You will just need to show your graphs. Now on this, you don't need to show the graphs when there aren't any, but on the test there will be some. So for our word problems, your test is 2 sections, solving systems with word problems. Which of these 2 do we want to do? 1 and 2?
Oh, no, wait.
Yeah. 3. Let's actually not do 1 because we just did 1 like that. We can do 3, maybe. We can do 2 and 3. All right, and number 2. Sorry. Madison bought two chicken sandwiches and 3 bowls of vegetable soup for $16.50. Not including tax, Cliff bought 1 chicken sandwich and 3 bowls of vegetable soup for $9.50, not including tax. What is the cost of a bowl of soup? What's important here?
2 chicken sandwiches.
2 chicken sandwiches, 3 bowls of vegetable soup, $16.50 total,
Cost about 1 sandwich.
and then 1 chicken sandwich, 3 bowls of vegetable soup, $9.50. What are we looking for? How much this soup costs? Now I'm going to let you guys choose. How do we want to solve this? By substitution, elimination, or graphing? Actually, we just did graphing, so substitution or elimination. Substitution, okay. So first, we need variables. What don't we know?
What is the cost of the bowl?
Cost of a bowl of soup and cost of the chicken sandwich. So let's use C and B. Sure. So C is going to be the cost of the chicken sandwich. So I'm not going to write all of that. And B is going to be the cost of the vegetable soup. I'm not going to write all of that. And we need 2 equations. You are going to use those variables and that total, but you're missing some numbers. You're going
Plus 3b equals 16.
so that's 1. Alright, we are solving this one by substitution. So we need those methods in our mind. We need to do what first with substitution? Solve a variable to get it by itself. Let's do this one since that variable is by itself. So C would equal 950 minus 3b. And then what? Substitute it into the other one. So I'm going to put this next to 2. So 2 times 950 or 9.5 minus 3b plus 3b equals 1650. Okay, and then how would we solve this? Distribute. So 2 times 9.5 is 19. Minus 6b plus 3b equals 1650. When we combine our like terms, how many b's do we have?
We have negative
negative 3. Okay, and then when we subtract 19, what is that? Negative 2.5. And then we have to divide both sides by negative 3. So what is b? Change it to a decimal. 0.83, so that's 83 cents. So remember, anytime you're looking for cost, you can have decimals. But if you're looking for amounts, you really shouldn't have decimals. And then in this case, we aren't asked to find the cost of the chicken sandwiches, so we don't need to do anything further. The vegetable soup. We were looking for the cost of a bowl of soup. Alright, for number 3, 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. It's also true that 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. What's the value of Jasmine and Josh's numbers? What's important here? Three times, I'm sorry, 4 times, 5 times.
It's so is it 5 minus?
Hold on. Which also means this second sentence is important. And then we're looking for both of the numbers. Now, we do need variables, but because we're looking for just numbers, we don't really need to define that it's Jasmine's number, Josh's number. But we do need 2 different variables. J and what? Let's not use L. Let's use H instead. So J and H. And then Mary, you started to say one of the equations.
5j or 5j minus 3h equals negative 16. And
Yeah, go ahead.
and the other one is 4j plus 5h equals negative 35.
So because it's specifically asking about numbers, we are just going to solve these. So we did substitution, we did a graphing one, we're going to do this one by elimination. So we have to think about how we solve by elimination. One, do we have a variable with the same coefficient? No. So we need to make something with the same coefficient. What do we want to eliminate? J. If we are eliminating J, we're multiplying what? 5 and 4 to what?
So 4 and 5 and 5 to
4 to the top and 5 to the bottom. Which would give us 2 new equations. 20J minus 12H equals negative 64. I'm running out of space up here. And then 20J plus 25H equals equals, what's 5 times negative 135?
175.
Negative 35. I didn't mean to say 135.
Yes.
Negative 175. Okay. If we're trying to eliminate these two, would we add or subtract? Subtract. 20j minus 20j is 0. Negative 12h minus 25. Negative 37h. And then negative 64 minus negative 175. 111 should be positive. Remember, the 0 doesn't really need to be there. And then divide, what is h? Negative 3. This will probably be the one time you have a word problem that gives you negative answers. Alright, and then we're going to put this back into one of the equations. It does not matter which one, so we can find j. I'm going to go ahead and put this back into this first one. So 5j minus 3 times negative 3 equals negative 16. Negative 3 times negative 3 is positive 9. How would we solve for j? Subtract 9 on both sides, so then we have 5j equals negative 25. What is j? Negative 5. So h is negative 3 and j is negative 5. For the next section of graphing, we can do 3 of these if we need to. If we don't, we can move on. 5.
Oh, wait, let's do 8. Let's do 8, 10, and 9.
So we already have 5. We can do 8. And you said 7.
9.
It's going to be about the same. Alright, so we're going to do one of these by hand, one in the calculator, and then I'm going to do one on Desmos. So for number 5, remember, however you're doing this, if you use Desmos or your calculator, you still need to graph these. How would I start graphing this top one? Y-intercept at 3. And then my slope is positive. What directions could I go to get a positive slope?
Down and left.
Up and right and down and left. So I can go up 1, right 3, down 1, left 3. And then for my other line, my y-intercept is 1. And then we have a negative slope. So what directions could we go? Down and right, or up and left? Alright, so from here, go up 1, left 3, down 1, right 3. That was terrible. What is our solution? -3, 2. Now, I should have asked this before we graphed this. Hold on one second. Not looking at our graph itself, just looking at our equations. Do they have the same slope?
No.
No, so we knew they weren't going to be parallel. The lines aren't equal, so they're not going to be infinitely many, so it had to be one solution. John, what was your question?
How did you get 3 and 2?
Get what?
3 and 2.
-3, 2, that's where they intersect.
But I didn't get that.
You should have, is what I'm saying. Number 7, I'm going to put in my calculator. So in y equals, put y equals 5x minus 4. Sorry, just 5x minus 4. And then -3x plus 4. I can't. I gotta wait for my calculator to come. If you get there, you can go ahead and graph your lines. And then go to second trace. You're looking for intersect. And then press enter 3 times. Yes. I'm about to do it, yes. Alright, so once your equations are in here, y equals, graph them, then go into second trace or calculate. You're looking for intersect, and then hit enter 3 times. You should get the intersection of 1, 1. Now, even though you graphed it on your calculator, you still need to graph it on the actual graphs on the test. And then for number 8, if you're solving it in your calculator or graphing it in your calculator, you would need to solve this for y. But if you're using Desmos, you don't need to do that, and you can just put these 2 in. Come over here and do that. Now, I had to zoom back in because I was really zoomed out. What type of solution would this have? They're parallel, so that means no solution. So you would need to graph the lines and just write no solution.
Wait, so in Desmos you can just enter it in.
You still have to graph it. But then yes. So if you're looking at just it, so here I can see that this goes through 4, this goes through -3. And I can see from here, this has a slope of something weird. 1, 2, 3, 4, 5, 6, 7, 8. It's like 8/3. Mine don't really look parallel, but they should be. Alright, now this next section says to solve by substitution, but if you are using Desmos, you are more than welcome to continue using Desmos. If you are not planning on doing substitution on the test, you can just use Desmos, or however you are going to solve them. But if you are planning on using substitution, then this is good practice. We can do up to 4 of these if needed. So there will be solving systems, and you choose how you wish to solve them.
Wait, so what is parallel lines mean?
I'm sorry.
What is parallel lines? Lines mean?
They have no solution. Do we want to do any of these?
Yeah, it's good one.
13. Okay. For 13, we need to solve this by substitution. So we need to get a variable by itself. Here, I see that this one is almost by itself, so I'm going to solve for that y. But it doesn't matter. You can solve for any variable. So how would I get this y by itself? Subtract 5x on both sides. Is y by itself? No. Not yet. So we need to divide or multiply by this -1 so that it is by itself, not in front of the y. Okay, and then we would do what with that? Put it into the other equation. So -5x plus 8 times 5x plus 19 equals -23. And then what? Distribute. -5x plus 40x. What's 8 times 19? 8 times 19. 152. Okay. Combining our x's, we have positive 35x.
Wow.
And then when we add 152 to both sides, what would that become? I'm sorry, go ahead. Oh, this was positive. That's why this looks off. So we're subtracting. what is x? Negative 5. But remember, we need to find x and y, so we need to go back and put that in. So it doesn't matter. I'm sorry, I'm thinking elimination. I'm going to put this back in here. So y equals 5 times negative 5 plus 19. What would y equal? What would y equal?
Nine.
Negative 6. Negative 25 plus 19.
Oh, that's
So our solution is negative 5, negative 6. Remember that just like for graphing, you will also be able to determine what type of solution it is if it's in slope-intercept form. So like looking at 15, do those have the same slope? No, so they won't. The answer won't be no solution. They're not the exact same, so the answer won't be infinitely many. It would be one solution, and you'd have to find that one. 18. We're going to do 18 and then do some elimination ones. For 18, notice that you don't really have something in slope-intercept form. You're given a number. That means substitute that number in. So anytime you're given a number instead of an equation, you will be solving less. So negative x plus 2 equals negative 6. Subtract 2 on both sides. And divide by negative 1. So our solution is 8, negative 2. There are 8 elimination problems. Would we like to do any of those? Okay. For 26, if we're thinking elimination, do we have a variable with the same coefficient? Yes. Our x's. Would we add or subtract to eliminate these x's? So if we add them, negative 10 plus negative 10 is the same thing as negative 10 minus 10. Would that get rid of them? No. So we need to subtract. Negative 10 minus negative 10 is 0. Negative 4 minus negative 3 is what? Negative 1. Or just negative y. And then negative 22 minus negative 29. 7. So the 0 here is not necessary. I tried to cross it out completely. It didn't work. And then we need to divide both sides by a negative 1. So y equals negative 7. But we have to go back and find x. So we can put this into either one of these, it does not matter. I'm going to choose the first one. Negative 4 times negative 7 is 28. And then how would we solve for x? Subtract 28. When we do that, what would that equal? Negative what, Kylie? I think that's right. So x is 5. So our solution is 5, negative 7. Do we need or want to do another one? You will have time to do that on your own. And then I'll be around if you have questions. I meant another one in this section. Okay. So for the remainder of class, I want you working through these. If you finish these and would like extra practice, I do have other things you could be working on if you feel like you need it, but do this first.